Alright, so a closer look at methods and classes. This chapter continues the discussion of methods and classes began in the preceding chapter. It examines several topics related to methods, including overloading, parameter passing, and recursion. The chapter then returns to the classes, discussing access control and the use of keyword static and one of Java's most important built-in classes, string. Overloading methods. In Java, it is possible to define two or more methods with the same class within the same class that share the same name as long as their parameter declarations are different. When this is the case, the methods are said to be overloaded and the process is referred to as method overloading. Method overloading is one of the ways that Java supports polymorphism. Alright. If you've never used a language that allows overloading of methods, then the concept may seem strange at first, but as you will see, method overloading is one of Java's most exciting and useful features. When an overloaded method is invoked, Java uses Java uses the type and or number of arguments as its guide to determine which version of the overloaded method to actually call. Thus, overloaded methods must differ in type and or number of their parameters. While overloaded methods may have different return types, the return type alone is insufficient to distinguish two versions of a method. When Java encounters a call to an overloaded method, it simply executes the version of the method whose parameters match the argument used in the callback. Okay. Here's a simple example that illustrates method overloading. Okay, so we have class overload demo, we have void test, no parameters, then we have int a and b. Alright. Overloaded overload test for a double parameter. Right. Then we have class overload. Okay, class overload demo. Alright. We have class overload. Overload demo. This is new. Okay, alright. So we tested this, okay, overload demo and the class overload. Alright. Okay, so as you can see, test is overloaded 4 times. Okay, I'll make a new folder here. Overloading methods, right? Overload.java. Alright. Overload methods, this will shows the different type of method overloading. We have class overload demo, create a void test, the test, okay, void test, it takes no parameters. Then we have another one, Overload test for one integer parameter, overload test for two integer parameter. Okay. Overload test for one integer parameter. And we have int test, int a, then we can overload test for two integer parameter. System dot out dot println a and b. Then let's overload test for a double parameter. आ गया.
हवा में तो आराम तो कर लेगा कम से कम जैसे था वैसे ही रहने दे हाँ ऐसे दिक्कत जाना है बेटा हाँ हाँ ऐसे तो आप आराम करते हो ना तो पंखे के नीचे रहोगे तो ऐसे इसमें खिसका रहे हो
Alright, so I'm going to overload test for a double parameter. Okay, hold up then. Alright, so overload test for a double parameter. And then okay, so we have, and it returns the square of a. Okay, then we move on to class overload. Okay, then we will create a new object of overload demo. Dude, I don't want to buy it. OD dot test, right? We call. Okay, so yeah, forgot to make the main function public static void main string args Alright, and we also create a double result. Okay, so we go od dot test, od dot test 2, od dot test 1 comma 2, and then we have result equals this. Okay. Result equals od dot test 0 point, okay, 1.5, yeah. Okay. Then we have system dot out dot implying we go with result of OB. Okay. One point five. Okay, let's try and run this. 14. Oh, it is actually a missing return statement. Oh yeah. D should be void. Should be void. And finally it works. Okay. Then we have, as you can see, test is overloaded 4 times. The first version takes no parameters, the second takes 1 integer parameter, the third takes 2 integer parameters, and the fourth take 1 double parameter. The fact that the fourth version of test also returns a value is of no consequence relative to overloading, since return types do not play a role. Return types do not play a role in overloaded resolution. Okay. When an overloaded method is called, Java looks for match between arguments used to call the method and the method's parameters. However, this match needs not always be exact. In some cases, Java's automatic type conversions can play a role in overloaded resolution. Okay. Here we go. Test I is 88. This will invoke test double. Ah. Alright, so there is. Okay, so in this example, there is no test int. So when we call test I, this will invoke test double. Okay, as you can see, this version of overload demo does not define test int. Therefore, when test is called with an integer argument inside overload, no matching method is found. However, Java can automatically convert an integer into a double, and this conversion can be used to resolve the call. Therefore, after test int is not found, Java elevates I to double and then calls test double. Of course, if test int had been defined, it would have been called instead. Java will employ its automatic type conversions only if no match exists. Okay. So we have method overloading supports polymorphism because it is one way that Java implements the one interface multiple methods paradigm. To understand how consider the following. In languages that do not support method overloading, each method must be given a unique name. However, frequently you will want to implement essentially the same method for different types of data. Consider the absolute value function. In languages that do not support overloading, there are usually three or more versions of this function, each with a slightly different name. For instance, in C, the function absolute returns the value of an integer, L returns the absolute of a long integer, and F returns the value of a floating point. Since C does not support overloading, each function has its own name, even though all three functions do essentially the same thing. Okay. This makes situation more complex conceptually. I still have to remember names. This situation does not occur in Java because each absolute value method can use the same name. Indeed, Java standard library includes an absolute value method called ABS. Okay. This method is overloaded by Java's math class to handle all numeric type. Java determines which version of ABS to call based upon the type of argument. Okay. Then we have the value of overloading is that it allows related type. Okay, so I'll I'll copy overload Java to overload2.java. So let's open this, remove this, and right. Since no overloading, there's no method of the type, test int was found. Can't find overload 2. Yes, my bad. First of all, we have to say this is overload 2. Yeah. Okay. We have the value of overloading is that it allows related methods to be accessed by use of common name. Thus the name absolute represents the general action that is being performed. It is left to the compiler to choose the right specific version for a particular circumstance. You, the programmer, need only remember the general operation being performed. Through the application of polymorphism, several names have been reduced to one. Although this example is fairly simple, if you expand the concept, you can see how overloading can help you manage greater complexity. When you overload a method, each version of that method can perform any activity you desire. There is no rule stating that overloaded methods must relate to one another. However, from a stylistic point of view, method overloading implies a relationship. Thus, while you can use the same name to overload unrelated methods, you should not. For example, you could use the name square to create methods that return square of an integer and square root of a floating value. But these two operations are fundamentally different. Applying method overloading in this manner defeats its original purpose. In practice, you should only closely Then we have overloading constructors. In addition to overloading normal methods, you can also overload constructed methods. In fact, for most real world classes that you create, overloaded constructors will be the norm, not the exception. To understand why, let's return to box class developed in the preceding chapter. Following is the latest version of box. So we have box double with this is the constructor, compute the volume. Okay. As you can see, the box constructor requires 3 parameters. This means that all declarations of box must pass 3 arguments to the box constructor. For example, the following statement is currently invalid. Since box requires 3 arguments, it's an error to called without them. This raises some important questions. What if we simply wanted a box and did not care or know what its initial dimensions were? Or what if we want to be able to initialize a cube by specifying only one value that would be used for all 3 dimensions? Okay. As the box is currently written, these options are not available to you. Fortunately, the solution to this problem is quite easy. Simply overload the box constructor so that it handles the situations just described. Here is a program that contains an improved version of box that does just that. Okay, so we have box with a width uninitialized, and then we have width length with this or alright. Okay, so as you can see, the proper overloaded constructor is used based upon arguments specified when new is executed. Okay, so we go over with I want to create a new one called overloading constructor. Okay, showing example of overloading constructors. So we'll create a class box, then we will create some int width, height and depth. We have box with no parameters, right? Okay, so width equals height equals depth equals okay, all are initialized. If no parameters provided, all are initialized to negative 1. Then we have box and len. Maybe I go double len. To the same value, right? Width equals height equals depth equals length. Okay, then all are specified to their specific values. Double depth, and then we can compute the volume. Let's create a main function. So let's create an object of box rent. So box, let's say p1 equals new box, then we have box p2 equals new box, say 5, and box p3 equals new box, so say 3, 4, 5. Right, and we have get the volume of boxes. B1 volume, B1 dot volume, B3, B2, B2, B3. Oh, my bad. Incompatible type. Oh, why do you declare all ints? Double. Alright, there we go. Okay, so then we have, as you can see, the proper overloaded constructor is called based upon the argument specified when the new is executed, using objects as parameters. So far we've only been using simple types as parameters to methods. However, it is both correct and common